All right, here we are, Pkt6, class 23. Uh-oh. I see I didn't change this. All right, so this is already on. It's actually Monday. I think everything's right except the day. It is Monday, 17th. This is class 23. Let's see what we got here. Oh, ha, ha, ha. Take a look. Five more sessions. That'll finish May. Now, flash off. I showed the class that 42 pages. I started working on it this weekend, and I could estimate it was going to take me 2 hours just to get through all the who won and then against the playlist. Yeah, it probably came down to you guys or third hour, but I'm going to go with here's what I'm going to do. To keep it fair, and I told you this last time. On Friday, this Friday right here, at lunch, I'm going to be making hot dogs either outside on the west lawn with charcoal grill. We'll have chili cheese dogs. We'll have chips. We'll have desserts. We'll have drinks. Or if it's raining or very, very wet or muddy, we'll be inside. And in my fume hood, I only use a fume hood for one thing, and that's making hot dogs. So I get the best. I get like Nathan's dogs, I get the primo hot dogs. And first I boil them, then I put them on rollers, and we cook them. I had a student, his parents owned a restaurant, and they shut her down, so they gave me the roller. So we roll them, we get them just right. And so here's what I'm doing for those people that were participating. If you participated, your name's on the list of people that were actually trying in there swinging, you will get a free meal. Others will pay $3. That's one way to get a free meal. The other way to get a free meal is to bring a homemade dessert. If you bring a homemade dessert, you get a free meal because you're helping out. Okay. Otherwise, you can come in, get a dessert, get all that food for $3, and that's still cheap. That's still cheap. No tip required. So that's the cheapest lunch you're going to get, and you'll fill yourself up. Anyway, that's this Friday. With rain or shine, we're going to have it. It's either in the classroom or it's on the west lawn. Now, if it's in the classroom and you don't want to come up, that's your business. You can wear a mask. You can always come get your food in the room and eat it outside or eat it in the hallway or something if you want. So that's my solution to that dilemma I think it's a fair solution. The reason I really want you up there is I want to get this picture. I want to get a picture of you guys. I'm going to get a picture of everybody, and I'd like to have you in the official picture. And we'll take that sometime during lunch, probably about 12:30 or so. We'll take that picture. We're not going to have a Zoom that day, unless you want to learn about sex and HIV and AIDS. But you can always come to class for that one. Okay, so let's see what's happened in the next 2 weeks. 2 weeks. Last night I handed out I put online the PDF. Handed them out today, and I forgot to bring some home to put on the front porch, but I'll try and do that tomorrow. But it's available online. Yeah, so that was available as of last night. With taxes due today, and I'll show you what I was doing all day yesterday. I haven't had time to do much else, but I did get that take-home test written. Bad news. Bad news, good news. The bad news on the take-home test is that I tried to squeeze it down to 2 sides. It was too much. I was having to leave off really important stuff. So I said, okay, I can make the font like 7-point. You need a magnifying glass to read it, or I can just go 3 sides. So the bad news is it's 3 sides, which bumps up the points to 200. out of 150. Instead of 150, it's 200. But the good news is about a side's worth we're going to end up doing together. So if you have it in front of you starting tomorrow, we'll probably start working in on it. All right. So we'll chip away at that partly in class. So it'll still be the same usual 2 sides at home, but one side will be, I mean, it's all at home for you, but one side will be like during these sessions, we'll do some of it. Okay. At least get you going on them. Okay. And if you look at it, the first 2 sides, we've done all that. The third side, we haven't done much with. So that's what we got to really concentrate on this week. 5 more sessions. This doesn't really apply to you, I guess, unless you want to come up and help. Students are helping me starting to box up everything in my room and my prep room because they're going to put down new tile. They're going to paint all the walls. So they're going all crazy in the science building. So I've got to get everything off the walls and I got to get everything into boxes. So we are doing that now. If you want to come up, I'm giving 4 stamps a box. And if you want to get there, say at noon, you can work from noon to 1 on it. I have students right there, probably right now. I know they're done by now, up there working. When I left, they were working. So there's plenty to do, trust me. So you box up books, you box up equipment, and you just set it there, and then they're going to take it on the hallway on the 28th. So, and I'm offering 4 stamps, which for you is up. They talked me into it. I was going to say 2 stamps. First hour talked me into 4. They wanted 5. I said, no way. So we negotiated at 4 stamps a box. A stamp's 3 points. That's 12 points a box. And it's not that hard to do. The boxes aren't that big. They're like this. Just throw stuff in there, put a number on there. So if you'll help me there, that saves me. On Thursday this week, I'll have available for you by PDF, probably the Pkt6 organizer. Friday we talked about. Thursday night, Thursday we'll do our usual Zoom at 1:10 to 2 o'clock, but then Thursday night from 9 to 10, we'll do a Zoom help for the take-home test, and I'll record it, of course. I'll keep it as organized as I can for you, because some people work or they're going to bed that time, whatever. It may, when I wrote this, I was thinking 2 sides, but now it's 3 sides. It may go all the way to 10:30, but anyway, there'll be a recording of it. And then we get into test week, the final week of the year. You've got to have submitted. Everybody has to do it. This is for online and for you guys. I'm sorry, for virtual and for in class. You've got to submit online take-home test 6B by 1:10 p.m. because you know what happens at 1:10 p.m. That'll be our last official session here. And what we'll be doing there is going over the take-home test. Okay. And this time, not just this time showing you how to work them all, not a help session, actual key. That's why you have to have the thing turned in. If you don't have it turned in, you automatically lose something like 50 to 75 points out of 200. You lose 50 out of 150. So you'd lose 75 out of 200 if you waited till, say, 2 o'clock to turn it in, because then it's not fair. You have a key right there. That's crazy. Okay, the 25th is the test. Now, if you want to come in for that test, if you've been vaxxed up, you feel comfortable, certainly I would love to have you come in and sit for that test in classroom with everybody else. You don't have to, but if you want to get it over with on the 25th, I know some of you are going on vacation, and like Rose and stuff needs to come in. That's fine. It's open notes. If you're going to do it virtually, you won't get it until Wednesday. Okay. But what we're doing, you know what? That Monday will not be our last session, because we're going to need to have a Zoom on Thursday to go over the test for you to get your black and blue points. They're going to come in on Wednesday and Thursday, whenever the day is for them. This is the schedule. Whenever ours is 55th hour, but no, I'll be gone by then. So they'll be coming in. So on Thursday, yeah, because I just noticed I'll be up there. I will not be here Wednesday. I'll be at school during our normal time here, but we're not meeting Wednesday anyway. But Thursday, the 27th, would be the day that you would get your black blue. So the district wants us to have everything done, all grades in by the morning of the 28th, yet they want us to give a final. That's ridiculous. Plus the 27th, that's graduation, so we can't even work on it. So it's ridiculous. So my retort to that is, I ain't giving a final. I mean, that basically is the final. Okay. Which is okay in physics, because physics is accumulation of a lot of things. And so it makes sense that the test 6B would be the final. We're only giving a final to kids who are making C's and D's and F's anyway. And to me, why that just adds, insult to injury. I mean, they're obviously having a hard time taking a test. Then you give them a test. It's stupid. So instead, what they're going to be doing is helping me. They're going to get lots of stamps. Each kid can do up to 10 boxes at 4 points, 4 stamps a box. That's 40 stamps. That's 120 points, which would certainly help with your 300-point test. So a lot of kids are going, yeah, I'm doing that. So they'll be up there both Wednesday and Thursday after their hour long. We'll do them black and blue. And to be honest with you, I'm not going to have much time to grade anything. So they're going to get it back, their test back, with a black and blue pen, and we're going to fix it. And they're going to get the points right there. They're going to grade it right there on the spot. I have zero time. District gave me zero time to grade anything. Okay. So any questions in the next 2 weeks? Kind of complicated. I'm not saying this won't change some, but that's pretty much it. My best guess right now. Any questions over the next 2 weeks? Okay, looking ahead then, June, and I'll show you a promo here in a minute, but that's what June's schedule looks like. We start on the 3rd. That first one, the first Zoom we do for our June physics will be live from Austin, Texas. I'll be hanging out with my brother's house. We're down there helping my son move, and so doing some other stuff. So I won't be back in Norman until the 6th of June. So that's okay. It's Zoom, right? So he has good internet. So I will be at my brother's first one, doing the Zoom, going through some stuff, explaining how things will work. And then we'll be back for all the rest of the stuff. I just yesterday secured another tour. We're going to do a tour of both physics buildings. And this is a tour of one of the research facilities, a big time research facility at OU, from Dr. Richter. I've been trying to get this for a while. So he's a really good, very informative guy, and he's like the head of his department. So a good guy to know right there is worth your $30, just to know the right people. Yeah. So reasons for doing it, I think, would be just learn. You're going to learn a lot of physics that you didn't have time to get to. And, we'll do a cookout. We'll do all that kind of stuff too. It's summertime, so it's pretty relaxed. There's not really tests. The only test I would give would be just little small ones, just to see, just between you and I, just to see how you're doing. So it's pretty relaxed environment. You would get a certificate at the end to kind of prove that you did it. And then that way you can put it on your resume, and it'll say something like physics summer seminar or something like that, where on your resume, you're trying to separate yourself from all these other students that have had physics or that have had 4.0 grade point averages. And you got to find ways to say, look, I did this, you didn't. And so having said to say summer 2021 physics seminar, me signing off on it, that's good. So, it's normally 120. I'm giving it to you for 30 because you are kind of my guinea pigs. Okay. I put this up there just because I was getting a lot of trouble from some of them that I didn't really do work for Parnassus, and I didn't really know the mystery man. And this is our storyboarding we did. When we did that, we were putting together, this is the one I put together, and then this is our launching point for our game. And we developed a game for Galileo to go around to be, you were either Galileo or you were his companion. You had choices. And this kind of follows him around Venice and Pisa and all these places he went and all the influences he had. So this was the storyboard that we started with. And from there, 2 months later, we had a game. These are all the correspondences we had back and forth, just because my students are going, no, you didn't do that. I like I say, man, I didn't get an education to lie to you. There's that. We didn't go around. Question.
Mr. Aspie.
Yeah.
So was the game like a mobile game?
Yeah, it was like first person, like you would there was all kinds of stuff involved because we knew to keep kids' interest. There were all these doppelgangers and stuff, and you had to like it was a puzzle to get to the next levels. You had to get to levels, and there were ways to get to levels. You could also time travel. This is a retro back to an old Star Trek. You could time travel, and that got you into. You weren't stuck with Galileo. You could also we were also building Charles Darwin. We had Charles Darwin built, at least the avatar for him, and then we had Einstein. We had all kinds from all different sciences. It was really starting to come together when my boss was killed. So it's too bad. And then no one really took up the mantle. And so the whole thing, without him, he was the creative source. This guy was a genius. I couldn't hold a candle to him. So once he was gone, then that pretty much died after that. And I've always thought somebody else would maybe start it because we have the beginnings of a game, and people that were gamers, the people that were writing this code, but then they didn't have they weren't getting paid anymore. So, okay. Now we're not going to do Joke Monday, but I will show you a promo that I put together. This is what I spent all day yesterday doing. This is a 1-minute promo. And I'm going to stop that sharing, get a new one. Share this. There it is. Okay, so here's a promo for what's happening in June. Hope this works. This is going to run on the Roar tomorrow and Thursday. Put them on.
Am I smart or not?
Okay, going back here. I messed up. Now for the big finish. Took me, that was an entire day. Took me almost all day yesterday because I did not know how to use iMovie. I had no idea how to use GarageBand, and I was going to put like Beach Boys music in the background. Well, YouTube will stop that pretty quick. So I made up my own little tunes on GarageBand. It's kind of fun, but it does take a lot of time for 1 minute worth. So that's our first promo. Not exactly the most professional, but free. Didn't cost me anything. We don't got any money. All right. So hopefully you were inspired by that, and you will join us in June. And I always say, I've had people ask about it. I said, well, why don't you sign up for the first week? You can sign up by the week. It's like $30. I think it's 30. They throw $2 fee on there, but $32. And then if you don't like it, you can always quit. And then you're only out $32. Well, for you sign up for the first week and then you're good for the rest. You buy 1 week, get 3 weeks free. Okay. So think about it. Join up. Well, back to work here. So chemistry of friction is what we were talking about on Friday. And that is London dispersion forces, right? So today we'll get into this more and we'll get into it. We're staying with friction. We'll keep thinking we're going to get through friction. Then we got more stuff comes up. So that's the LDFs. Everybody okay with that much so far? Are we good there? Okay. I showed these because we can also that's a picometer scale. That's 10 to the negative 12th. If we go to a micrometer scale, 10 to the negative 6, go a million times bigger, then we have this kind of stuff. And I found this one. What is that? Anybody know what that is? I don't know if I showed this Friday. You might know what that is. Remember, that's a millionth of a meter across. That is nylon pantyhose. It makes sense, right? Stretchy. What is this right here? We're on the micro scale. What is that?
A toothbrush head.
Ah, good guess. Good guess. Does kind of like a toothbrush head. No, that's Velcro. Doesn't make sense. It has little hooks. Velcro. Okay. Last time we talked about Coulombs Law. We'll mention that again today. Today I was having them hold magnets. We passed around the room and they hold these magnets. And obviously when the magnets get close, they snap together, but you can start to feel them. The idea was when you started to feel it. But if you pull magnets apart this much, you don't feel them because the R squared, that the electric positive, if it's electricity or charges, the positive, negative, in that case, attraction is, this far apart, they don't attract unless they're really big magnets. Electromagnetism, electricity and magnetism go together. So this is true for friction when they're that far apart on a picometer scale. The further apart you go, the less they attract. And so that's really the basis of how this whole industry, these chemical engineers can work to form substances that either want to be sticky, like say you're making the soles of someone's boots that they're hiking up mountains, and they want them to be able to hike up say a 45-degree incline, which is incredibly steep if you're on it. And that'd be a black diamond. No, that'd be even worse than a black diamond on skiing. Black diamonds on skiing are probably like 30 degrees. So we're talking 45 degrees. If you want to hike up that, you need a high amount of LDFs. So in that case, you want the electrons when they form, you want them so that those electrons and then the surfaces are not so far apart. And there's a micro scale to it and a picometer scale to it, that the attraction of one protons for the electrons of the other would be enough to give you a lot of those. So you'd be sticky, not glue, but sticky. And then, or like they make those special gloves in football, right? Sticky gloves for professional football players. So they catch that ball. That's all legal. Sometimes you want it so it doesn't stick. You want those things to be like paraffin wax. We'll talk about that in a minute. So then we talked about this graph some more, and what we were talking about was this knobby part. I call it the knobby part, that knobby part right there, and what was causing all that. So we'll get to that today. I found this. I think I added a bunch of these. If you looked at the screenshots, and I'll add this again this time, but I added a bunch of screenshots from last Friday. But this is a big one here. This is the best graphic I've seen on what used to be called van der Waals forces, and in honor of Fritz London, we call them London dispersion forces. Van der Waals is more of a general term meaning attractions. But if you have some, and they made it kind of a nebulous shaped object, anything where there's more electrons on one part than the other, that is a partial negative. They made that blue. And then over here, where there's less electrons, it's partial positive, and that's going to cause attraction. And that little three red dots or 4 red dots, dot, 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 that is LDF. That's an LDF. Okay. So there's where how your LDFs are forming. All right. And that is not a bond. Student today said, so that's like a covalent, or no, it's not ionic bond. Electrons are not exchanged. It's not a covalent bond. Electrons are not shared. It's not a metallic bond. Okay. It's not a sea of electrons. It is an attraction. All right. There's an attraction there. If electrons made the jump, that'd be a spark. We're not talking about sparks. There is an example of one surface going over another, peak to peak. Okay, when you get down to that micro scale, that Velcro kind of shown, that's peak to peak. I'll put all this stuff on there. Here is a textbook version of it. I think it's kind of a simplified version. It's peak to trough. This is when it's not, when, like I said on Friday, I take the Himalayas, I flip them over, I put them on top of the Rockies, and then I kind of shake them down in there. And then that is the peaks of the Himalayas, like, K2 and Mount Everest, are going to get stuck down in the valleys between, Pikes Peak and Mount McKinley. So you would have these peaks into valleys, and then to get that thing started to move, that would be hard to do, because look at all these little blues. Those are all the London dispersion forces that are being formed because it's so close. So one of the reasons for this knob is you've got to get this to, you want to go from here, okay, which is like this peak to valley thing. Is a more realistic peak to valley with all these LDFs. You want to get from that to this peak to peak. Like if I did start to push those Himalayas, flipped over Himalayas over the Rockies, once I get going, I'm heading from Mexico to Canada. Once I get going, I'm going to be shearing off just peaks. It doesn't have time to settle in. Well, as we said with LDFs and Coulombs Law, that R is way too big for any kind of big R, right? Any kind of attraction to form positive, negative, the R is too big. And so on peak to peak, yes, you do get some LDFs, but here I have 6 LDFs. Here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 to 11. So you see, you're in that area where you're in that knobby area where there's more, it's less chaos. There's a lot of chaos over here. That's why they always show this kind of jaggedy. This is out of a textbook, but there's always more jaggedy in the kinetic friction range than the static friction. I like what this book called it. This book called it the threshold of motion. I think that's better than calling it a knobby part, but I call it the knobby part. But threshold of motion is a more fancy way of saying the same thing. So this is a graph you're going to see when you get up to college, and I want you to know what it means. We blew through this in about 5 minutes in college. I didn't understand what he's talking about. And we're not going to talk about this, but we could easily spend a day on lubrication, like 10W40, motor oils, things like that. Ball bearings can be used as lubrication or as to things to reduce friction. And they do that. They have there's lots of viscosity and stuff that gets involved there. And once again, it comes down to London dispersion forces. But the amorphous nature of the fluid gets it kind of it reduces the amount of friction. There's a lab we do with that too. We haven't done that in years because it takes too long, but it's kind of cool. But you could, once again, you could spend the rest of your career just developing better lubricants. You know, back, I was telling my kids, is back in the 1800s, you know what the only really good lubricant there was? They didn't have 10W40. They didn't have that kind of stuff. They didn't have, you know, motor oils and stuff until they got cars and internal combustion engines. I guess they did because they had steam engines and stuff. But the best lubricant was pale whale sperm. Pale whale sperm. When they would go whaling, they would cut up the whale for all the blubber and all that kind of stuff. But the prized possession was the pale whale sperm. I don't know what the thing sold for by the ounce, but it was the best lubricant you could get. Because I looked up in a book one time and I saw, what? Pale whale sperm? What? And then looked it up and said, yeah, that was a big deal. Okay. So the rest of the time here, the next 19 minutes, we're going to look at 10 and 11, mostly 11. Now, number 10, this is on 6.8. Number 10, 6.8. I know we're not going to finish Pkt6. I'll tell you on Thursday what all you have to have. But number 10, normally we would go around the room and I put 10 stations out and I have 10 different surfaces, some rough, some smooth, and then there's little books underneath them. And so then there's things that got to slide on, like wooden blocks. And what they do is they keep measuring, they keep raising one end until the thing starts to slide, the block starts to slide. And that's called the angle of repose, angle of repose. That is called theta rep. And that is the angle at which objects start to slide. So if you are designing the roof of a house and say you're in Alaska and they have a lot of ice, a lot of snow up there, you're going to go and look up in a book the coefficient of friction, the static coefficient of friction between ice and composite, whatever your roof is. Then maybe metal because it's even lower. And then you're going to look and see what is the angle of repose, what's the mu sub s, and then that'll determine what angle you want the pitch to be for that roof so that this stuff will slide off. So keep in mind, angle of repose, if I show this here, a book, my iPhone, what angle can I keep raising that book to until the iPhone starts to slide? See, right where it starts to slide, and the key phrase in physics is just about to slip. When you see that, just about to slip, that means we're talking about angle of repose. Okay, so we can put skip on that. We did go around, and that's empirical because we just determined it, what the angle of repose was. And you're getting 20 degrees. We have a calculator in that room that'll do 70 degrees. You can have the thing at 70 degrees. That calculator finally starts to slide. The little tips on it. Let's do number 11. We'll spend the rest of the hour on number 11, the next 16 minutes. When I was at OU as a freshman, not a freshman, I think I was a sophomore when I took physics. My first physics class, Dr. Cohn couldn't be there one day, so we had a guest physicist, and he was from England. And so he would say, yes, the angle of repose. Yes, quite. The angle of repose, you see. And so let's always think of that guy. So with angle of repose, here's what we're trying to find. Now, notice that is at an angle. And so the first thing you want to do is tilt your axis. So let's tilt our axis on this one. It's a weird looking box. It's going to, we want the angle of repose. We want the angle at which it just starts to slip. Okay, so I'll give you a minute and you now draw the free body diagram for that. The tilted on this is XY. Draw the free body diagram. I'll give you a hint. There are three forces. So I'm going to push pause for about a minute. Okay, so we were talking about REI and boots and determining angle of repose. So they were to have all my virtual kids were supposed to have just now gotten the free body diagram. So I will put on what we did in class. I made them go to the board. All right, so we have MG. Always got that guy. We have normal, right? There is solid contact. So clap, there is a clap. If there's clap, there's solid. And so we have normal force. Just make these as, long enough. The length isn't so important right now. We're not doing head to tail. And then there is a friction up the incline. That is F sub S. I had some students make F sub K. No, that's not slipping yet. It's just about to slip. Let me kill this guy. So this is F sub S, which is the same thing as mu sub S times N. Okay. Now, from this, that's it. Those are your three forces. And from this, we have to derive. Now, this is not on the take-home test, but remember, it's legal for me to hold back on 10%. So this might be the 10%, part of the 10% I hold back on. 30 points worth. So we've got to, I'll go ahead and give it to you, what the equation is. And that's what you've got to determine. That's what I made them determine. So theta rep equals, believe it or not, the inverse tangent of mu sub S. Any chemical engineer would know this if they work in this field. That's the equation we are trying to derive. And we are starting with this setup. So at this point I said, okay, go to the board. They already had the drawing set up. So go to the board now and figure that out. So you guys have 11 minutes to figure this out. I'm going to pause it again and let you work on it. All right, so I'm going to pause for 2 minutes. All right, so we're back on the air here. I don't know if you did this or not, but you should, when you have a vector at an angle, you should go ahead and make that a right triangle. And so here I'm going to make this MG a right triangle. It's actually the diagonal of a rectangle. Yeah, I'm going to do it. I didn't do it in class. I'm going to do it that way though. So we know we have this, and then we have this. I'll use both sides like that, pretty much. Okay. And no, I say color it in, but boy, there's a lot of things to color in. I need to know. Let me make this a little nicer than class. I need to know what that angle that I'm erasing here. I need to know that angle. This angle right here. Let's go to a different color. Let's go blue. I want to know that angle. And I'm going to highlight that, the triangle I'm talking about. For that right triangle. Now, use your geometry. Okay. That is 90 degrees. So if that's theta rep, if this is theta rep, then isn't this complementary to that? The complement of theta rep. This is also, and I have a help video on this somewhere. This is, because this bothers students, this is also 90. So then what is this? Here's the key thing. What is this angle down here? What is that angle? which is, by the way, the same as that angle. These are congruent. So what are these angles? I'll make it in black. Anybody have an idea?
45 degrees.
Not 45. This is the key to the whole problem. This angle is theta rep. That'd be theta rep. Theta rep. You can prove it to yourself. Theta rep meaning angle of repose. And that's actually, I'm trying to make this, I'm trying to make this real fancy here. There's really two right triangles here. Okay, so why do I care? Well, if that's theta rep, then isn't this leg right here red? Isn't this leg right here? This is mg sine theta rep. And this is mg cosine theta rep. Agreed? That's for this leg. Who's with me? So now we do summation of forces. Now the key is, I got 5 minutes. The key is just about to slip. It's at the precipice of slipping. So we'll have summation of forces in the X, tilted X, will equal 0. It isn't slipping, but it's just about to slip. Otherwise, it wouldn't be called theta rep. It'd just be called theta. So in the X direction, we have direction of potential motion is down the incline, even though it's not moving down the incline, the direction, because you got to put friction opposing, right? So we have mg sine theta rep. That is this, right? That is this guy, that part down, the part of the mg that is down the incline. It's a component minus mu sub s times n equals 0. Okay. Now I'll give you a minute and you do the y. And we know that box isn't levitating or sinking. So it's also equal to y it's also equal to 0 in the y direction. So equals 0. For the y direction, summation of forces equals 0. So in the y direction, we have, and summation of force in the y equals 0. In the y, we have normal up minus, well, now it is a component of mg, but this time it's that component, mg cosine theta rep minus mg cosine theta rep. And that equals 0. Now from those two equations, we got to put those two equations and out comes that equation. This is about where the bell rang in class. So what are you going to do?
If they both equal 0, wouldn't they just equal themselves?
Exactly. They can equal each other if they equal 0, transitive property. That's one way of doing it. I got no problem with that. Yeah, I think that sounds good to me. So we got a minute or two. So let's keep going here. So we have mg, write it all out, sine theta rep minus mu sub s times n equals n minus mg cosine theta rep. right? Set them equal to each other. That was not a good idea. I'm not saying it wouldn't work. That's messy. How about I do it this way? I got a better idea. I'm not saying that won't work, but look, how about if we solve this guy, the second one, in terms of n? Solve that in terms of n. So n equals mg cosine theta rep, right? Now take that and sub that in for n right there. That'll work better. And then you'll see the mg's cancel, and then you can get your sine over cosine as tangent. So I think you can get it from there. That's probably the best approach. But I am going to run out of time. So maybe we'll wrap that up in the first minute or so of tomorrow's class. But I think you can do that much. Now, would that appear, would I be mean enough to put that on the test? Maybe. Because I know there'll be a black and blue day coming the very next day. So, but if you want full credit on it, you'd get it right the first time. Okay. Any questions? Crazy schedule. Keep watching it. It's on the cover of the canvas. If you have any questions, stick around. Otherwise, I'll see you guys tomorrow.
I have a question on
Yeah.
6.5.
Okay, go ahead. If I can find it. I think I may have
On-
deleted it. What is 6.5?
On number, it's the F
And by the
equals
way,
MA.
By the way, I posted the key to that, Keys.
Yeah, I saw the key, but I still want to understand it.
Okay.
On 2C,
That's 6.6. I don't even know if I have 6.5 anymore. I don't have it. What so tell me, give me the name of the tell me what it's about.
it just says what will be the maximum altitude of the rocket? What would be the maximum altitude the rocket will
Right.
achieve?
So you're gonna have so while the engines are firing, it's gotten a certain height, right? You can use you can find acceleration and all, and then you can find the delta y with that acceleration. So you'd use orange. You'd probably use either the second orange, I think, on that one, to determine its height. Okay. Then the thing has got momentum rising, right? So after that, you would then use free fall, because once the engine's shut off, it's like a rock. So it's not a rocket, it's a rock. And so it just keeps going up because it has momentum. So at that point, you use like third blue. You would know the initial velocity. The initial velocity of free fall is the final velocity of when it was accelerating. And then you would know the velocity at the peak would be 0. So you could use third blue to find the additional height you get because it has momentum. And then you add the two heights up, and that gives you the total altitude when it turns around.
All right, thank you.
All right. See you later.